Okay, dear students, so till now we completed total 118 questions with detailed solution and some 5 to 6 extra questions also. Okay, so I think more than 120 questions till now we completed. Fine. Now let us take next question. Question number 119. Okay, this is also very much important question. Question number 119, guys. Question number 119. Question number 119. Okay, so how to solve this question? So x of t, whose Fourier transform x of j omega, which is nothing but 8 sinc square omega by pi, then which of the following waveform corresponds to x of t, guys? X of t. Okay, sinc square here. You are getting sinc square omega by pi. Okay, so standard format you have to remember. A triangle function from a triangle function from minus t to plus t with amplitude a. With amplitude a. A triangle function from minus t to plus t with amplitude a, then its Fourier transform is given by x of omega is equal to a square t sinc square ft or a square t into sa function, sa square, or you can replace f with sinc square f. So omega is equal to 2 pi f. F is equal to omega by 2 pi into t, guys. Okay, remember this thing. Okay, a square t sinc square omega by 2 pi into t, or simply you can remember a square t sinc square ft, guys. Okay, now here this is what, guys? 8 sinc square omega upon pi, which is nothing but 8 sinc square omega equal to what? 2 pi f. 2 pi f. Okay, pi get cancelled out, which is equal to 8 sinc square twice f. 8 sinc square twice f. Correct? So standard format a square t sinc square f into capital T. Okay, so if you compare this one, then t equal to 2, guys, and 8 is equal to a square t. So a square t is equal to 8. So a square is equal to, wait, a square is equal to a square into t is equal to 8. Okay, so a square equal to 4. So here here a square equal to 4, that's why a is equal to plus 2 guys. A is equal to plus 2, correct? A is equal to plus 2. So here option C not possible, option D also not possible. A square t is equal to 8, where t equal to 2 guys. So t equal to 2, so a square equal to 4, a square equal to 4, so a should be 2 guys, a should be 2 here. So this is standard format, minus t to t, a square t sinc square ft. Okay, so here a should be 2 guys, here a should be 2, but here it is given 4, here it is given 4 guys. I think here a equal to 4, so just wait for a minute. A equal to 4, a equal to 2, minus 2 to 2, a square 2 equal to 8, t equal to a square equal to 4, a equal to 2 guys, correct. Eight sinc square omega by pi 2 pi f. I think maybe printing mistake. So later we will see guys, later we will see. I think there is some mistake, because the Fourier transform of a minus it is sinc square ft. Okay, sorry, my mistake guys, here not square guys, my mistake, here not square, simply it is sinc square ft guys. Yes, here my mistake, here not a square guys, here not a square, simply it is sinc square ft. My mistake guys, here not a square t guys, here simply it is sinc square ft guys. Remember this thing, it is sinc square ft, so here not a square guys, my mistake. That's why a equal to 4 guys. Yes, my mistake. So here a is equal to 4 guys. Yes, a equal to 4, that's why option A is the correct answer. That's why option A should be right answer of this question. So remember this thing, a Fourier transform of triangle pulse from minus t to plus t with amplitude A, it's a Fourier transform a t sinc square ft, and you can replace f with omega by 2 pi. Here it is given a t sinc square omega by pi, so a t sinc square omega by pi, omega equal to 2 pi f, so pi get cancelled, twice f, so a t sinc square ft, so t equal to 2 and a t equal to 8, so a equal to 4, so a equal to 4 and t equal to 2 guys. This is minus 2, correct? So option A is the right answer of this question. Option A is the correct answer of this question. Fine, option A guys. Here the right answer should be option A. Now next question, this is also very much interesting question. Next, question number 120. Question number 120. For which of the following function Fourier transform does not exist? For which of the following function Fourier transform does not exist? Okay. Now remember this thing, Fourier transform is defined only for stable signal. Remember this thing, absolutely integrable, that means stable signal. Okay, Fourier transform is defined only for this stable signal. Okay, now they are asking does not exist guys. E power minus at into u of t where a greater than 0, so it is nothing but exponential decaying function, so it is a stable, that's why Fourier transform is defined. Now here e power minus at, e power minus a mod t where a greater than 0 guys, where a greater than 0. Okay, e power minus at where a greater than 0. So again same thing guys, see e power minus a mod t, that is equal to e power minus a, let us consider a equal to 2, suppose a equal to 2 mod t, so it is nothing but e power minus 2t into u of t plus e power 2t into u of minus t. So this is nothing but exponential decaying both this side. See, so here also this is stable signal guys, so for this also Fourier transform defined. Now this one, e power at into u of t for a greater than 0. That is e power suppose 2t into u of t. Correct? A greater than 0. So now you can see this is what? At t equal to 0. At t equal to 0, 1, and it is exponentially increasing function. So that's why it is unstable, guys. Unstable. So here for C, for option C, Fourier transform does not exist. Now e power at into u of minus t, where a positive. Let us consider e power 2t into u of minus t. So it will be what? Exponential decaying. Left hand side signal. See negative value of t. So it will be exponential decaying function. Left hand side. Left hand side. So this is also stable. So for this also Fourier transform defined. So they are asking Fourier transform does not exist. So which option should be the right answer? For the unstable signal, Fourier transform does not exist, and here the correct option is option C, guys. The correct answer for this question is option C. For option C, for this signal, Fourier transform does not exist. Correct? Does not exist. So this is question number 120. This is the question number 120. Now next is question number 121. Yes, this is also very much interesting question. Okay, question number 120, guys. Question number 121. Okay, question number 121. So how to solve this question? So f1 of t, now see here, this function is real and it is even function, guys. Correct? And this is what, guys? This is real and odd function. Yes or no? You can see, guys. This is real and even function. This is real and odd function. So remember this concept: x of t corresponding Fourier transform is x of omega, or you can write x of j omega. Now here this is even, odd, even. Here also even, odd, and same as Fourier series. So it can be real, it can be imaginary. X of omega, it can be real, it can be imaginary, guys. Now see, if x of t is real and even, then corresponding Fourier transform will be even and real, and vice versa also true, guys. Okay, vice versa also true. If it is x of t is real and odd, then corresponding Fourier transform will be odd and imaginary, guys. Odd and imaginary, and vice versa also true. Similarly, if x of t is imaginary and odd, then its corresponding Fourier transform will be odd and real, guys. Odd and real. Correct? And if x of t is imaginary and even, then corresponding Fourier transform is nothing but even and imaginary, guys. Even and imaginary. Okay, so tell me which option should be right answer. As f1 of t is real and even, corresponding Fourier transform will be real and even according to this. Now as f2 of t is real and odd, so corresponding Fourier transform will be real and odd. So you can see odd and imaginary, or imaginary and odd, guys. So out of 4 statement, how many statements are correct? So you can see, guys, CTFT of f1 of t is real and even. Yes, first statement is true. CTFT of f2 of t is real and odd. No, guys, it's a odd and imaginary. So second statement is wrong. CTFT of f1 t is imaginary and even. No, wrong. CTFT of f2 of t is imaginary and odd. Yes, this is right. So how many statements are correct for this question? So 1 and 4 are right. So that's why option B is the correct answer of this question. Option B is the right answer of this question. Fine. Option B, guys. Option B is the correct answer of this question. Fine. Now next, question number 122, guys. This is also very much important question. Question number 122. Question number 122. If x of t is an odd function of t, then Fourier transform of x of t can be evaluated by. Okay, odd function of t, guys. Odd function of t. Odd function of t. Then the Fourier transform of x of t can be evaluated by. Okay, this is also very much interesting question, guys. This is also very much interesting question. So x of t is odd, guys. Correct? Odd function of t, guys. X of t is an odd function of t. The formula for the Fourier transform of x of t is nothing but minus infinite to plus infinite x of t e to the power minus j omega t dt. Now e power minus j theta, that is cos theta minus j sin theta. So x of omega will be minus infinite to plus infinite x of t. This is cos omega t minus j x of t sin omega t, Euler's form, sin omega t dt. Okay, so integration is a linear operation, that's why you can do the separate integration, individual integration. X of t into cos omega t dt minus j integration minus infinite to plus infinite x of t into sin omega t dt. Now see, they are saying x of t is a odd function, guys. So cos is a even function and x of t is odd function, guys. X of t is odd function, correct? So what is a multiplication of odd multiplied by what is odd multiplied by even, guys? Odd signal like t cube multiplied by even signal like t square, so it will be odd. So multiplication will be odd, guys. Okay, and what is the integration of odd function from minus infinite to plus infinite? It will be 0. It will be 0, guys. This will be 0. Yes or no? Correct? This will be 0, guys, because multiplication will be odd function and integration of odd function from minus infinite to plus 1 will be 0. Similarly here this is x of t is a odd function and sine also odd function. Odd multiplied by odd, nothing but even. So total multiplication x of t sin omega t. X of t multiplies sin omega t. X of t multiplies sin omega t will be even function. Okay, and integration, see minus infinite to plus infinite. So you can do integration from 0 to infinite and you can twice it, guys. So minus 2j integration 0 to infinite integration 0 to infinite x of t into sin omega t dt, correct? Minus 2j. So which option should be correct answer? Minus 2 times, guys. 2 times 0 to infinite. So minus 2j x of t sin omega t dt. Odd function. So cos omega t minus j sin omega t. Okay, so minus sign should be there. Minus sign should be there, guys. Okay, minus sign should be there. Okay, here x of omega is equal to minus sign should be there. Okay, minus sign should be there. So let me check once. 2j, this first term will be 0 and minus j, so 0 minus infinite to, okay, so minus sign should be there, guys. Here in option C minus sign should be there. Okay, minus 2j 0 to infinite x of t sin omega to omega t dt. Okay, so option C, guys, here minus sign should be there. Okay, because we are getting minus sign, minus here present, e power minus j omega t, Fourier transform x of t. Yes, okay, option C, guys, option C should be correct answer of this question. Now next, okay, next, okay, okay, next 1 to 4 guys, 1 to 4, question number 1 to 4. Okay. So the Fourier transform of signal x of t equal to e power minus mod t is x of j omega equal to 2 upon omega square plus 1. This is given. Then the Fourier transform of y of t equal to 4 cos 2t upon t square plus 1. Very much interesting question, guys. This is very much interesting question. Okay. So remember this thing, one property. If Fourier transform of x of t is x of omega, then if you multiply x of t with cos omega ct, okay, modulation property, then spectrum will shift right side and left side by omega c, and the amplitude is decreased by factor of 2, guys. Okay, remember this thing. Okay, now here e power minus mod t and its a Fourier transform is given 2 upon omega square plus 1. Okay, 2 upon omega square plus 1. So duality property we can use, that is 2 upon t square plus 1. Its a Fourier transform will be 2 pi e to the power minus t become minus omega. Omega become t, then here 2 pi multiply and t become minus omega. So it will be 2 pi e to the power minus omega. Correct? So 2 get cancel out. Fourier transform of 1 upon t square plus 1 is nothing but pi e to the power minus mod omega. Now see here, here it is multiply with cos 2t, guys, 4 cos 2t. So 4 cos 2t divided by t square plus 1. So according to this modulation property, 4 and it's a Fourier transform, that is pi right shift by 2, guys, because omega c equal to 2. So right shift by 2 plus pi left shift by 2, and amplitude is decreased by factor of 2, guys. So finally x of y of omega, here y of t is there, that's why y of omega will be 2 pi into the bracket e to the power minus omega minus 2 plus e to the power minus omega plus 2. Correct? So which option should be right answer here? Which option should be correct answer? Here the right answer is, the correct answer is option C. Option C is the right answer of this question. 2 pi into the bracket e power minus mod omega minus 2 plus e power minus mod omega plus 2. Okay, this should be a right answer of this question. So this is question number 124. Okay, now this is also very much interesting question. This is also very much interesting question. What is the energy of signal x of t equal to e power minus 18 to u of t in the frequency band? In the frequency band mod omega less than or equal to 0.5 radian per second. Okay, this is also very much interesting question. Now Parseval's energy theorem, guys. Energy of x of t you can calculate in time domain as well as in frequency domain. In time domain formula is integration minus infinite to plus infinite mod x of t square dt, and in frequency domain 1 upon 2 pi minus infinite to plus infinite mod x of omega square d omega. Okay, this is the formula, guys. Now they are asking in the frequency band mod omega less than or equal to 0.5 radian per second. Correct? So here x of t is given, x of t equal to e to the power minus at into u of t. Then it's a Fourier transform is given by 1 upon a plus j omega, 1 upon a plus j omega. Correct? So according to above property, x of energy of x of omega, this formula 1 by 2 pi. Now they are asking in this band, meaning of this is nothing but what? Minus 1 by 2 less than omega, less than equal to omega, less than equal to 1 by 2, guys. That is here omega is minus 1 by 2 to plus 1 by 2. Correct? Mod omega, that is mod a plus j omega whole square d omega. Yes or no? Correct? Are you getting? So energy will be 1 upon 2 pi, here minus 1 by 2 2 plus 1 by 2. So it will be square root and square cancel out, a plus omega square d omega. So here what about integration? So 1 upon 2 pi, here 1 by a into tan inverse omega upon a, omega by a minus 1 by 2 to plus 1 by 2. Yes or no? Minus 1 by 2 to plus 1 by 2. So here this is nothing but 1 upon 2 pi a bracket tan inverse omega, that is 1 by 2a minus minus plus again tan inverse 1 upon 2a. Yes or no? So here energy is nothing but 1 upon 2 pi a into 2 times tan inverse 1 upon 2a. 2 get cancel out. So the right answer is option A. Option A is the correct answer of this question. Fine. Option A is the correct answer of this question. So this is question number 125. Question number 125, guys. Okay. Question number 125. Now next question. Okay. Consider a triangular pulse x of t is shown in figure. The Fourier transform x of t is given as x of j omega is equal to 1 by omega square e power j omega minus j omega e power j omega minus 1. The Fourier transform of x2 of t shown in figure is dash. This is also very much interesting question, guys. Directly also you can do, guys. Directly also you can do. What happened? A square plus omega square. Okay, here a square. That is my mistake. A square, guys. A square plus omega square. That is true. A square plus omega square. Okay. Here a square plus omega square. So directly also you can do, guys. It's a Fourier transform is nothing but at sinc square f into t, guys. Fourier transform triangular function where this is minus t to t and this is amplitude a, guys. So here a equal to 1 and t also equal to 1, guys. So 1 into sinc square f into 1, guys. So it is nothing but what? It is nothing but sinc square f equal to omega by 2 pi. So sinc square omega upon 2 pi. Correct? Omega upon 2 pi, guys. Okay, but here see omega by 2 pi. So sinc square, see this is omega by 2, guys. Here this is omega by 2. Okay, here omega by 2. So here option A should not be correct answer. Omega by 2 pi. Sinc square answer should be sinc square omega by 2 pi. Omega upon 2 pi, correct? A equal to 1, t equal to 1, it is sinc square ft. Option A and B not possible. Now we have to check option C and option D, guys. Option C and option D we have to check. Okay, then how to solve this question? How to solve this question? So we have to find the relation between x of t and x2 of t, guys. X of t and x2 of t. Okay, now see. First of all, this function, guys, this one, okay, and this one, guys, correct? So can we say here, can we say this is nothing but x of t minus 1, guys, right shifted, correct? X of t minus 1, that means this thing you will get, x of t minus 1, this thing you will get, guys, correct? Triangle x of t minus 1, are you getting? Now then folding with respect to of this one, guys, that is this thing is nothing but this part, this portion is nothing but x of minus t minus 1, yes or no? Minus t minus 1, first folding, first right shift, correct? Right shift by 1 second, so this is nothing but x of t minus 1, correct? Then folding with respect to y axis, guys, that is 1 and minus 1 and 0, guys, minus 1 and 0, so x of minus t minus 1, so x2 of t is nothing but here x2 of t is nothing but x of t minus 1 plus x of minus t minus 1, guys. Now x of omega is given, x of omega 1 by omega square 1 upon omega square into the bracket e power j omega, e to the power j omega minus j omega e power j omega minus 1, correct? This is given. Now t minus 1, guys, so what is this? Is the Fourier transform of x of t, guys. Then what is the Fourier transform of x of t minus 1? So simply you have to multiply e power minus j omega, time shifting property, because of minus 1, divided by omega square e to the power j omega minus j omega into e power j omega minus 1, correct? So here it is, okay. Now next is Fourier transform of x of t become minus t. So t become minus t, that's why omega become minus omega. T become minus t, guys, t become minus t, so omega become minus omega everywhere. So here in this omega become minus omega, so e power j omega, here omega square into the bracket e power minus j omega, here minus minus plus j omega e to the power minus j omega minus 1, guys, okay. Now we have to add these two term, guys, we have to add these two term. So if you give inside, then it will be 1 by omega square, here this is 1 minus j omega e to the power again 1, guys, minus j omega minus e power minus j omega, correct? Here if you multiply inside, guys, are you getting? Correct. And here if you multiply, then 1 upon omega square, this is 1 plus j omega minus 1, j omega minus not 1 minus e power j omega, correct? Now we have to add these two things, guys. So Fourier transform of x2 of omega, So 1 upon omega square is common. 1 minus j omega minus e power minus j omega plus 1 plus j omega minus e power j omega, correct? Now this cancel out and it is nothing but 1 by omega square into the bracket 2 plus this is cos, guys, minus 2 cos omega. This should be correct answer, guys. So out of 4 option, which option should be correct answer here? Sin omega, okay. Let me check once. 2 e power minus j omega upon omega square cos omega plus omega sin omega minus 1 and 4 by omega square 1 minus j2 omega minus e power minus j2 omega. Okay, let me check once. So this is x of t minus 1. So this one here, okay, right shifted, okay. Then folding with respect to y-axis, that is x of minus t minus 1, x of minus t minus 1, okay, minus t minus 1. So x of omega is this one, e power j omega minus j e power j omega minus 1. So x of t minus 1, so e power minus j omega upon omega square, remaining term same, so multiply inside 1 minus j omega minus e power minus j omega, okay. Then minus t minus 1, so omega become minus omega. So here in this answer omega become minus omega, omega become minus omega, here also omega become minus omega, omega become minus omega minus 1, yes. And if you multiply this thing, that is 1 plus j omega minus e power j omega, okay. Next you have to add both the things. So 1 minus j omega minus e power minus j omega plus 1 plus j omega, so it's cancel out. So 2 minus 2 cos omega, answer should be this one, okay. So we can check option C, guys. Let us check option C. So 2 e power minus j omega divided by omega square bracket e power j omega plus e power minus j omega divided by 2 plus omega e to the power j omega minus omega e power minus j omega divided by 2j minus 1. So if you multiply this inside, so 2 by omega square, here this is 1 plus e power minus j2 omega divided by 2 plus omega minus e power minus j2 omega divided by 2j minus 1. No, I think this is not possible. So here two answers are possible. One is sec square omega by 2 pi and one more is this one, guys, 1 by omega square 2 minus cos omega, 2 minus 2 cos omega, correct? 4 sec square omega by 2. No, you are wrong. 4 sec square omega by 2, no. A into t, guys. Here t equal to what? Here you can see a equal to 1 and t equal to 1, guys. Okay, according to this one, already told you. Here minus t to plus t, amplitude is a, then the Fourier transform is 80 sec square ft. 80 sec square ft, so here a equal to 1 and t also equal to 1, guys. Here a is equal to 1 and t also equal to 1. So a into 1 sec square f, t equal to 1. So it is sec square f. So it is f equal to omega by 2 pi. omega by 2 pi. Correct, omega upon 2 pi. So I think maybe mistake in, and this is correct approach guys, this is correct approach. So this answer is possible, and one more, this answer possible guys, this one, sec square omega by 2 pi. Okay, so okay, let us take next question. Question number 127. See, question number 127 guys, this is the question number 127. Okay, okay, so here see, Fourier transform of x of t, Fourier transform of x of t is nothing but x of omega. Then Fourier transform of x of t minus 1 is nothing but e to the power minus j omega x of omega. Then Fourier transform of minus t minus 1, t become minus t guys. See, here t minus 1, t become minus t, so omega become minus omega. Omega become minus omega x of j omega into x of e power j omega into x of minus omega. Okay, now here x of t plus 1, so x of t plus 1, so e to the power j omega x of omega. Okay, and again t become minus t, t become minus t, so omega become minus omega. Correct. So what is the Fourier transform of this one guys? Fourier transform this one is nothing but summation of these two guys, e power j omega into x of minus omega plus e to the power minus j omega into x of minus omega. So x of minus omega is common, then here e power j omega plus e power minus j omega, which is nothing but 2 times cos omega. So which option should be correct answer? So here which option should be right answer? Here the correct answer is 2 times this one. Okay, now let me check previous one guys. Question number 126, what we got? 1 by omega square. See, x of omega is nothing but 2 by omega square 1 minus cos omega. So it is nothing but 2 by omega square. So here this is 2 times sine square theta, 1 minus cos 2 theta divided by 2. Okay, so it is 4 by omega square into sine square omega by 2 guys. Correct. Okay, now see here 4 into sine omega by 2, here omega whole square. Are you getting whole square? Can we say like this? Yes. So here divide by 2, multiply by 2. Okay, divide by 2 and multiply by 2. So these 2 with a square come outside. So 4 by 4 into sine omega by 2 upon omega by 2 whole square. So 4 get cancel out. 4 get cancel out. So finally x of omega will be, this is nothing but sine x upon x, correct? Sine x upon x, which is nothing but sa omega by 2 whole square. Okay, now omega is equal to 2 pi f, correct, divide by 2 whole square, correct, which is nothing but sine pi f upon pi f, yes or no, whole square. Psi x equal to what? Sin x by x, 2 get cancel out, sa pi f, so sin pi f by pi f. So this is nothing but what? Sinc, as I told you, sinc square f, see here, sinc square f. Are you getting? Sinc square f, yes or no? See, again we got the same answer, sinc square f. I told you guys here, again sinc square f, we got the same answer, correct? So this one and this one is right. That means there is a mistake in question. I think something mistake in question here. It should be omega by 2 pi, correct? Okay, so here this is right answer. Sinc square f is correct, as well as this our answer 1 by omega square 2 minus 2 cos omega also correct answer. Fine. Okay, so this is question number 127. Correct. Next question number 128, guys. This question is from DTFT. Okay, the Fourier transform of the signal summation m equal to 0 to infinite a power m into del t minus m, where mod a less than 1. Okay, so here let us draw this signal. See, put m equal to 0, guys. If you put m equal to 0, then it will be, if you put m equal to 0, then it will be what? 1 into del t, that is impulse at impulse with magnitude, with height 1 at 0, guys. Put t equal to 1, guys. Sorry, m equal to 1. Now see, mod a less than 1, guys. Mod a less than 1. So a power 1, guys. A power 1. So it will be what? Impulse with amplitude 1 by mod a, 1 by a at m equal to 1, guys. M equal to 1. Correct. Again, put m equal to 2. That is nothing but impulse. So 1 upon a square, 1 upon a square, correct? Again here 3, guys, that is 1 upon a cube, and so on. Yes or no? So this is nothing but a discrete function. Okay, we can write like this: x of m. Can we say like this? X of m is nothing but a power m into u of m, where this is m, guys. Correct? Can we say like this? Can we say like this, a power m, where mod a less than 1, where mod a less than 1, correct? Where mod a less than 1, okay, where mod a less than 1. So what is it? It's a Fourier transform. So it's a discrete function. So x of e power j omega DTFT 1 upon 1 minus a e power minus j omega, where mod a less than 1. Why? Because DTFT defined only for this stable signal, that is absolutely integrable signal. So this will be absolutely integrable only when it is decreasing, guys, decreasing. Okay, and it will be decreasing only when mod a less than 1, guys, correct? Because m value positive here. So which option should be correct answer here? 1 upon 1 minus e power minus j omega, option D. Here option D should be correct answer of this question. Okay, so 1 upon 1 minus e power minus j omega. So option D should be correct answer of this question. So total 128 question till now completed. Okay, 128. This is question number 128. DTFT. Fourier transform means this is the discrete function. So that's why DTFT. Okay. So let us finish this class here, guys, and next part we will continue into subsequent module. Thank you, guys. Thank you so much.